So for this problem, there says there's 64 girls and 16 boys, but it's just interested in the true proportion of girls. And again, it says it here, the true proportion of girls, construct a 92% confidence interval. So the first step would be to do P prime which is 64 divided by the total. 64 plus 16 gives us 80, so we have P prime. So 64 divided by 80 gives you 0.8. The second step is to do Q prime. Q prime is 1 minus P prime, so it's going to be 1 minus 0.8, so you get 0.2. The third step is to find the standard error. So you have the standard error equal to P prime times Q prime over N. So you have 0.8 times 0.2 over N, which is 80, your total number of students. And so 0.8 times 0.2 gives you 0.16. 0.16 divided by 80 gives you 0.002, and then you take the square root of that, and you get 0.0447213595. So if you look at the normal table, the only critical values are given for 90, 95, 98, 99. If we're looking for a 92% confidence interval, we're going to have to use StatCrunch to get a very accurate answer. If you did it by hand just to see an estimate, you would put 0.92 in the middle. 1 minus 0.92 gives you 0.08. 0.08 divided by 2 is 0.04. So you have 0.04, and you would go to the normal table and look for 0.04. 0.04 is up here. 0.04. The closest value would be the closest value would be right here. Right, so that corresponds to a z-score of negative 1.70123445. So negative 1.75. So that's step 4, z equals negative 1.75, and then you do your error bound for the proportion, which is your z-score times your standard error. So we're going to do 1.75, and I'm just going to use the positive version of it because you're going to end up adding and subtracting this, so the sign doesn't matter here, times your standard error, which is that long number up here. And when you times that by 1.75, you get 0.078262372, and then the last step for the confidence interval is to do P prime plus or minus your error bound for the proportion, and P prime was your 0.8, and you're plussing and minusing your error bound, which is this. So I'm going to store that number in my calculator, and I get 0.8 plus x, which is 0.87826, and then 0.8 minus that error bound, which gives you 0.721737. I would do this whole problem in StatCrunch to get a more accurate answer. So you do stat, and we're going to do proportion stat since we're given a proportion. One sample with summary, and we are looking for a confidence interval of 92. The number of successes is 64. The number of observations, or the total, is 80. And then 92% confidence interval, and then compute. and we get 0.7217, which is the same as what we got by hand, and 0.87826.